Alright, I wanted to make a little video here to clarify what I was talking about in class and on that recording of my expectations for this week and the assignment that we're going to do with this very simple XOR function cipher. I feel like I could have made it a little clearer, so I'm just going to make this video to help you if you need it. And I'm just going to quickly review the first things that we did in that and talk about the foundation of this. So in this file here, this REPL, which is now officially REPL.com, by the way, we have our binary converter, which just takes a letter and turns it to binary. And here's our text converter, which does the exact opposite. It takes text and converts it to binary. It takes binary, converts it to text. And then here is our XOR function, which basically just does exactly what the XOR function does, except it's a little cleaner and easier to do here. Reminder, XOR in Python is the caret. But basically what it does, it's like addition with binary, but binary is only zeros and ones. So if we were to XOR these two strings of binary here, then you can see what I'm talking about. So it's sort of, well, it's just like addition. You go to line them up like this. It's a little easier when you do it by that way. And you look at the first row, get that out of the way. First row is 1 plus 1 is 0. Normally that would be 2, but essentially XOR is addition in modulo 2. So 1 plus 1 is 0, 0 plus 1 is 1, 1 plus 1 is 0, 1, 0, 1. Now this wasn't really a great example because there were no two zeros, but let's say we had something like this. The resulting after the XOR would be 1, 0, 0 after these three, because a 1 and 0 produces a 1, a 0, 0 makes a 0, and a 1, 1 makes a 2, which goes down to 0. But basically, that's just a little more foundation for how this is doing it. And I'm going to quickly discuss the XOR cipher is what I'm calling it. It's sort of like doing a Caesar cipher, but with binary instead. So, for this cipher, you're going to have your text as well as a key. Now, your key won't be a number, it'll actually be a letter. And basically, how this will work is it'll take, I'm going to put this up so I can see the binary codes here. You'll take your text, and then you'll do the XOR function using the binary of the original text, the plain text, and the code for the key. And then once you've used the XOR function, that will produce your enciphered binary. So let's say, for this example, our text is banana. Actually, we'll do something short on that. We'll do boy. And our key, we'll just say it's D. Okay? So I'm going to go through this by hand, and then hopefully you should be able to replicate this in your code. Now, we're going to start with our binary for boy. We have our B, which is 1, 2, 3, 4 ones, 4 zeros, and a 1. All of these are 5 total numbers, 5 zeros and ones. And we go to find O, and then that is 0, 1, 1, 1, 0. If we space, we can highlight the D and find that. We're going to need the Y first, though. Look for the Y, there it is. 1, 1, 0, 0, 0. So this is our plain text converted to binary. This is what you're going to use on this binary convert in order to do this XOR function. Similar to like with the Caesar cipher. Before you could apply the shift, you had to turn it into the position of the alphabet. H became 7, A became 0, and then you would apply that key shift. Here we are going to do something very similar, except our key is now a letter, not a number. Don't get confused though, we're still basically just taking this binary number. This is just a way to define it so that it's easier to send to your ally and say, hey, the key is D versus, hey, the key is 00011, if that makes any sense. So we're going to go through here, and then we're going to do our XOR function by hand. D is 3 zeros and 2 ones, and you do it for every single chunk of binary here. When we do our XOR function, we kind of look at this here. We got zeros there, and then a 1, 0. I have a good amount of experience doing this XOR stuff by hand, but you can see it's very simple. 2 ones become a 0, 2 zeros become a 0 and a 1 becomes a 0. So this is our enciphered binary. So we took our plain text binary, well, we took our plain text, turned it into plain text binary, and we took our key, turned it into a key that would go into it. Normally you wouldn't have to create it that goes the whole length. You could just say plus the position of the key in your for loop. And then we have our enciphered binary here. Now, for this assignment, you can just leave your ciphered binary as is. You can have your encipher function, whenever it outputs, it could output this, and that would be fine. And then you could take your decipher and input binary, and then it returns the plain text letters. If you wanted to, though, you could return your enciphered definition function with plain text and binary, but for the time being, it's fine just to have binary. But I'm going to also go through and kind of go by hand and see what this would normally be. So 3 zeros and then 1 0. We can look up there. That is C. If we go to the next one, 0 1 1 0 1. And that is N. You look up here. We go down to the next one. It's very simple. Right now we're just sort of a scavenger hunt. And that's a question mark. Oh no, actually that's an exclamation point. But it's a little bit different with the binary because it involves more characters than just the 26 of the alphabet. So it could look a little confusing to see parentheses, dashes, exclamation points, but that's just the way that we have this set out, to go with the 5 characters all the way up to 1111, starting from 00000. So this would be your enciphered text for boy using the key D. Hopefully that helps you understand what this cipher is doing. Now, I referenced a little earlier what you're going to put in your for loop, and if you remember, originally what we did was, for a Caesar cipher, let's say, our for loop would say something like for I in our plain text, and then it would, take our plain text, convert it to our plain number, and then we'd go down and go all the way through. It's going to be a little bit different this time. What we're actually going to do is we're going to take our for I in plain text, and then we're going to turn our plain text into the binary of plain text. Then, once we have our binary for the plain text, we are going to do our key. Our key will become, this is not proper syntax, so I just want to show you guys. You'll take the binary of the key, your binky. So, once you have those two, you've taken your original and you've turned it into binary, then you just have your cipher binary. Excuse me. Your cipher binary will simply be your your binary plain XOR your bin key, which you can use this function inside this function as well. You don't have to recreate this. You can just say, instead of doing all this, you can just say XOR of, and then use the proper syntax that it tells you to use here. From there, it should be fairly simple. If you remember from what we have done in previous units, you're going to want your, of course, output equals the open string, and then your output will equal, plus equals, because it's adding to it every time, our cipher bin. And then this should be able to get you the result you're looking for. Of course, you're going to want this outside the for loop, but it's very, very simple and very similar to the Caesar cipher we have done previously. If there are any questions, feel free to DM me and let me know. This should be a fairly simple way to start us off using modern computational tools in order to encipher and decipher messages. Thanks for stopping by.